So timing and spacing are two key principles of animation. So if you haven't looked that up, I would highly recommend, and this goes to everyone, highly recommend looking up and reading about the 12 principles of animation. These are principles that we use day to day whenever we're animating to help make sure that our shots feel alive and appealing and interesting. Doesn't mean that they always have to be applied, but if they're not applied, there should be a reason why they're not being applied. We don't just drop them willy-nilly. But timing and spacing is basically two aspects of a similar thing. It's how do objects move. Timing is how long does it take for something to get from point A to point B. So how long does it get from one side to another? How long does it take to get from one pose to another pose? It's the timing of the shot. You could also think of it as the rhythm of the shot. So think of it like musical beats. If you think of kind of musical notes, if you've studied music, we don't want a shot that just has all the same musical beats over and over and over and over and over. Just like that. That would get boring. It's da 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 da. It gets boring. The timing is even. Instead, we want our timing to be interesting. We want dynamic moments, slow moments, fast moments. So we exaggerate our timing. So we would have a long note followed by maybe, even without changing the notes, maybe some fast notes here. And then maybe just a couple of regular notes. So suddenly that is a little bit more interesting. Slow, fast, 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 slow, slow. So we get this dynamic timing. The timing is the musical cadence of the shot. It's the beat of the shot, the heartbeat, you could almost say. Spacing is how an object gets from point A to point B. How does it traverse that space? So, for example, let's say we had an object here and it's going over here. And let's actually do this with animation. So we've got our object there. Let's bring in the timeline. I'm going to do this in 2D just for something different. So on frame 1, we've got our object right here. Now, if we go through this, let's say we'll go 10 frames. So on frame 11, right here, the object will be here. So now the object goes, and it takes 10 frames to get from one side to the other. That's the timing. 10 frames. The spacing, again, is how does it get there? As we go through this, does it favor one side versus another? Does it move in an arc? How does it move? It doesn't change our timing, but it changes the feeling of the shot. So for example, here, what if, let's see, right there. Get my brush back in here. Oops. And there we go. Can draw again. So does it go right in the middle? So our spacing is going to be from there to there, spacing chart to there. Or is it going to be over here? Is it going to ease out? That's spacing. Eases out. So I can add more keys here and just have this object ease out, come through, and then let's have it ease in a little bit right there. Okay. So now if we play that, let's actually go to the beginning here. Whoop. We get something like that. So it's a little slow and then fast. Our timing is the same. It got from point A to point B at the same time, but the way it transitioned is different. Now, a key exercise that I recommend most of my students do, especially the early students, like students who are totally new to animation, is this. So I'm going to create a polygon sphere, and let's go to the side view here and turn off our grid. Don't need to see that. I'm going to take this and I'm going to hit Shift D to duplicate it, and then move it up. And then I'm going to hit Shift D again a few times to duplicate it a few times. You can do as many as you want here. Let's actually do this in the front view. The view doesn't really matter, honestly. So we've got that. We've got all these spheres. Now I'm going to go on frame 1, set a key on all of them, then go to frame 48, or sorry, 49. So it's a 48 frame animation. Set a key. Okay. So frame 1 to frame 49. On frame 49, I'm going to move them to the other side of the screen. There you go. They all move together. The timing on this is 48 frames. They get from pose A to pose B in 2 seconds. That's the timing. Spacing, again, is how do they get to that point. And this is where you can make them do whatever you want. So, for example, if we're going to just set keys, let's not even focus on the graph editor yet. As this second sphere, we'll leave the top one kind of as the default. Let's make the first sphere hold a little longer. So it takes a little bit more time to take off. So maybe by frame 16 here, I'll set a key and just bring it back. So now from frame 1 to 16, it doesn't move as far. So it's easing out. Now, as it comes in, maybe by frame 35, it's already past the other ones. It's going to ease in some more. And we get that. The timing stays exactly the same. They start and end on the same frame. But the spacing is different now. So you can set the keys to start understanding that. As you look at the graph editor, you can do the same thing. So let's take our third sphere here. So the third sphere, let's do this a little differently. Let's say we want this one to take off. So now I'm going to do the same thing. I'm going to go in here. This one I want a little faster. So by frame 11, I want that to really go fast. Go there. And you can look at the graph editor and see what difference that makes. As you move that, it goes faster. Bigger difference right there. Then as it goes through, maybe it'll just ease in like so. So now we have one that shoots off and comes to a nice slow stop. It's all spacing. This is all just adjusting spacing only. We could do it in the graph editor. And this is where it can be very beneficial because it helps you understand what the graph editor is doing. So let's take a look at this sphere. As we're looking at the graph editor, there are really just two things that you want to focus on in the graph editor. One is the timing. How long does stuff take to go from one point to the other? So frame 1 to frame 48, or frame 49, I should say. That's your timing. But really, the main thing is how fast is it going in between? And the way you look at that is how steep is the curve? If the curve is flat, it means it's not moving very fast. If it's steep, it's moving quickly. So looking at this curve, slow, fast, slow, flat, steep, flat. So what that tells us is that it's easing out, slow, speeds up, and then it eases in. What happens if we want this to hit the end? So imagine like a bouncing ball where it's going to bounce and hit against the back wall over here. Well, it's not going to slow in. Let's say we throw it in as hard as we can, and we want it to bounce against that back wall. Well, we want that hit to be fast. So the curve needs to be steep. If I take this tangent here and just do this, let's look at that curve. Flat, steep, 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 steep to the steepest, which basically means slow, fast, hit. So if we look at the ball here, slow, fast, hit. So it's really just that. It's the speed of that curve. If I don't have the control that I have here that I want, I can add another key, and let's exaggerate a little bit more. So now we've got this really going in for that slam. So now it's going to be really slow, slams into the end there. Let's actually add a few more frames just so we can see it settle. So, and it just locks into place. That's it. So we're looking at the speed of the object. Flat curves are slower, steep curves are faster. That's it. Now, the next thing we need to look at is the direction of the curve, whether it's going up or down. So, for example, let's take this sphere, and you'll see that the curve is continually going up. In this case, we go from here up to that key. This just means that the ball is going in one continual direction. What direction that is really doesn't matter. It could be going up or down, left or right, in and out. It could be rotating, whatever. When we look at the curve, all we need to focus on is that it's going in one direction. If we see something else though, let's do this. The curve goes down, then back up. Well, that tells me that the attribute that I currently am looking at, in this case translate x, has a change of direction. It's going in one direction. Again, does it matter what direction it is? Not really. It's really just whatever direction it's going in. So it's going in one direction, down on the graph editor, and then it changes. It goes up. So if we look at it visually, it goes left, change of direction, come back right. Left, then right. Now, the reason why I say it doesn't matter which direction is because it really depends on your camera. So for example, if we look at the balls here, left, then right. But what if I turn the camera around here? Right, then left. What if I move the camera here? Away, towards. It doesn't matter. Your camera can rotate around your objects and there's no left or right space anymore. It's just that the translate x attribute is changing directions. That's really all we need to focus on. So with those two things, the speed of the curve and the change of direction, we can look at the graph editor and start to see the matrix, start to see what is happening in any animation just based on that. So for example, let's just take my curve here and let's do this. I'm going to add a key right in here, bring it down. Let's break those tangents. Boop, like that. So, like so. And we'll do something like this. Okay. So, what's happening to this sphere? What is going to happen? Without looking at the animation, we haven't seen the animation play whatsoever. What is happening? Well, it's our translate x. Now, if you're analyzing this and you're not sure, okay, what does translate x mean in this case? Well, just scrub through a little bit. Oh, okay, it's my left to right motion. Okay, got it. So my translate x, left to right. It's going in one direction and it's starting out slow, flat. It's faster, 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 faster. Then we get a change of direction. Now the curve, instead of going down, is going up. Change of direction. And it's going fast and then fast again. There's no ease here. It's just fast and then fast. This is a bounce. So it's going fast, changes direction very quickly, and goes fast. From there, keeps going, eases, slower, slower, slower. The curve changes direction again. So now we're changing direction. Slow, slow, fast, and then it hits. So we've got an ease out, a bounce, change of direction, a nice ease in and ease out with another change of direction. So it's going to slowly change direction and then just stop very sharply. We haven't looked at our animation yet. We've just looked at the curve. Let's actually look at the animation. There we go. We get that slow out bounce and then eases in and out and then hits. Once you know those two things, the flatness of the curve or the steepness of the curve, the speed, and the direction changes, you can analyze any animation in your graph editor and that's it. Don't need anything more. So yeah, hopefully that makes sense. And all of that is spacing. The timing was how long does it take to get from point A to point B? And technically you can break down timing even more. So for example, how long does it take to get from, in this case, point A to point B, which is back there, and then point C over here. So we can break down timing. Timing can be, what's the timing of the whole shot? What's the timing of a series of actions? So for example, if I'm a boxer and they're doing that like ball at the, like let's say, or just hitting a punching bag. Let's stick with that. So they're hitting a punching bag. What's the timing of all of the hits? How long does it take to do all of those hits? What is the timing of each individual hit? We can keep going down and down and down. Spacing is how does the object go from point A to point B? How does it do that action? So hopefully that makes sense. Hopefully that is clear and not too confusing. But I highly recommend doing this test just for yourself, for anyone who's kind of trying to figure out how to read the graph editor and how to understand timing versus spacing. This is a great little test to do. And just do as many as you can. Do 10, do 20 different spheres and make each one of them feel different.